Assalamu alaikum, dear students. Welcome to all of you in Network Professionals, the Cisco Networking Academy, and I am your instructor, Ahmed Malik.
Guys, welcome back to Introduction to Network Lecture 7. In our previous lecture, we discussed about Internet access technologies, home and small office Internet connection types, business Internet connections, and converged networks. Our today's topic is network architecture or a reliable network architecture. The main components of network architecture of today or a reliable network are fault tolerance, scalability, quality of service, and security. So let's take a start and elaborate all these points one by one in detail. Network architecture refers to the technologies that support the infrastructure that moves our data across the network. Have you ever been listen about busy networking online? Only you have the internet go down. As you know by now, the internet did not go down. You just lost your connection to it. It is very frustrating with so many people in the world relying on network access to work and learn online. It is imperative that networks are reliable and secure. In this context, reliability means more than your connection to the internet. This topic focuses on four aspects of network reliability. There are four basic characteristics that the underlying architecture need to address to meet users' expectation. Those are fault tolerance, scalability, security of service or quality of service, and security. The role of the internet has changed from a data-only network to system that enables the connection of people, devices, and information in a media-rich converged network environment. In the previous lecture, we discussed in detail about converged network. Converged network is a network in which we are using multiple services by using single line. For networks to function efficiently and grow in this type of environment, the network must be built upon a standardized or standard network architecture. Networks also support a wide range of applications and services. They must operate over many different types of cables and devices like routers, switches, firewalls, and so on, which make up the physical infrastructure. And also, we use many different types of cables in our network. The term network architecture in this context refers to the technologies that support the infrastructure and program services and rules or protocols that move data across the network. As networks evolve, we have learned that there are four basic characteristics that network architects must address to meet users' expectations, and those are fault tolerance, scalability, quality of service, and security. So let's move ahead and discuss these four different or basic characteristics in detail so that you can know more about a reliable and secure network. Fault tolerance, also known as redundancy or backup. A fault-tolerant network limits the impact of a failure by limiting the number of affected devices. Multiple paths are required for fault tolerance, redundancy, or backup. A fault-tolerant network is one that limits the number of affected devices during a network failure. It is built to allow quick recovery when such a failure occurs in our network. These networks depends on multiple paths between the source and destination If one path fails, the messages are instantly sent over a different link. Having multiple paths to a destination is known as redundancy. A simple example of this, if you have two internet connections at your home, if your one connection goes down, your traffic automatically shifted to another internet connection, and in this way you have no discontinuity in your network and you constantly remains using your internet connection. Reliable networks provide redundancy by implementing a packet switch network. Here you also need to remember that basically we have two main technologies to switch or forward our data packets. The first one is circuit switching, also known as circuit switch network, which one is an old technique, and using this technique we cannot take advantage of fault tolerance. And our latest one is our new technology which we are being used nowadays, that is known as packet switching or packet switch network. We try to know how packet switch network works. Packet switching separates traffic into packets that are routed over a network. Here you also need to remember that when we forward our data from source to destination, our that large data file is converted into multiple small packets with complete information from source to destination. This function is performed over OSI layer model 4, which is also known as transport layer, where our large packets are divided into smaller packets. Each packet could theoretically take a different path to the destination. This is not possible when we using circuit switch network or circuit switching, which established dedicated circuits between source and destination. Implementing a packet switch network is one way that reliable networks provide redundancy. Packet switching separates traffic into packets that are routed over a shared network. A single message, such as an email or a video stream, is broken into multiple messages or blocks are called packets. Each packet has the necessary addressing information of source and destination, and also they are using sequence numbers with each message. The routers within the network switch the packets based on the condition of network at that moment. This means that all the packets in a single message could take very different paths to the same destination. In the figure, the user is unknown and unaffected by the router that is dynamically changing the route with a link fails. Means that if a link fails, our routers automatically divert our traffic to another path on the basis of source and destination and other information mentioned in our data packets. In this condition, our users are totally unaware or not known about by using which path our data is reaching from source to destination. Another important aspect of a reliable network is scalability. Scalability means expansion in our previous network. A scalable network can expand quickly and easily to support new users and applications without impacting the performance of services to existing users. Network designers follow accepted standards and protocols in order to make the networks scalable. A scalable network expands quickly to support new users and applications. It does this without degrading the performance of services that are being accessed by the existing users. The figure shows how a new network is easily added to an existing network. These networks are scalable because the designers follow accepted standards and protocols by designing these networks. This lets software and hardware vendors focus on improving products and services without having to design a new set of rules for operating within the network. The network topology diagrams or network topologies consist of four routers with redundant links, including two connections to the internet cloud. Here in this picture, you can see that there are three local area networks or LANs are connected with these routers, one of which has been recently added. Additional users, by using this third new local area network, which is added in the network, can be connected to the internet without degrading performance of existing users. For network reliability or to more understand this topic, you must need to know about different type of topologies. As discussed in our previous lecture, there are bus topology, ring topology, and star topology. But nowadays, in modern networks, we are like to use Cisco two-tier topologies or three-tier topologies. Most of the networks or large-scale networks are using Cisco three-tier topology, in which access layer, distribution layer, and core layer. These three are main layers, and our networks are divided into three important layers, in which every layer has its own work, and if any device fails in our network, there is another device to take role of that device. In this way, we can have reliability in our network, and if we want to add new devices very easily, we can add new devices in our network. So if you want to know more about scalability, you must need to revise our previous lecture, or also you can find on internet Cisco three-tier topology models. Quality of service. Quality of service means that we need to use or we need to deal different type of traffics according to their needs, or provide useful bandwidth for different services. As you know that nowadays we are having converged network. We have already discussed about converged network, such network in which we are using data, voice, and video transmission by using a single cable that are known as converged network. Or if we are using many different types of services or technologies within same cable network, that is also known as converged network. Quality of service is the primary mechanism used to ensure reliable delivery of content for all users, as we need to give high priority to our video traffic. On the second phase, we need to give priority to our voice, and in the last, we need to deal with data. With a quality of service feature, we can create such policies. With a quality of service policy in place, the router can more easily manage the flow of data and the voice traffic. Quality of service is an increasing requirement of networks today. New applications available to users over networks, such as voice and live video transmissions, create higher expectations for the quality of delivered service. Have you ever tried to watch a video with constant breaks and pauses? Definitely, your answer is no. It's due to as data, voice, and video content continue to converge on the same network, quality of service is a primary mechanism for managing congestions and ensuring reliable delivery of content to all the users. If you are not facing such problem, it means that the quality of service is configured in your network. Congestion occurs when the demand for bandwidth exceeds the amount of available bandwidth. Network bandwidth is measured in number of bits that can be transmitted in a single second, or bit per second, BPS. When simultaneous communications are attempted across the network, the demand for network bandwidth can exceed its availability, creating network congestion. Means that when the demand for bandwidth increases than the available bandwidth, this condition is known as network congestion. Normally, we see such problems in peak hours. When the volume of traffic is greater than what can be transported across the network, devices will hold the packets in its buffer memory until the resources become available to transmit them. In the figure, you can see that one user is requesting a web page and another is on the phone call. With a quality of service in place, the router can manage the flow of data and voice traffic, giving priority to voice communication over data if the network experiences congestion. The focus of quality of service is to prioritize time-sensitive traffic like video on voice and voice on data. The type of traffic is important, not the content of traffic is what is important. Network security is more important for a reliable network, and in a few years or last few years, we have noticed that security has become an integral part of a network, and the main focus of every network infrastructure is on security, as security has become a main concern of every network. The network infrastructure services and the data contained on network attached devices are crucial personal and business assets. Network administrators must address two types of network security concerns. Number one is your network infrastructure security, means your physical security. And number two is your information security, means your virtual security, you can say. Securing the network infrastructure include physically securing network devices that provide network connectivity and preventing unauthorized access to the management software that resides on those physical devices as shown in the figure. When you are working as an information security admin, you need to protect the information contained within the packets being transmitted over the network and the information stored on the network attached devices. In order to achieve the goals of network security or information security, there are three primary requirements which are known as CIA: confidentiality, integrity, and availability. Confidentiality means that data confidentiality means that only the intended and authorized recipients can access the data and read the data. Data integrity means that assurance of users that the information has not been altered in transmission from origin to destination, means data on the way has not been altered or changed. Availability means that data availability assures users of timely and reliable access to data services. For unauthorized users means that authorized users can access data anywhere, anytime from any device.
That's enough for today, and stay connected for all upcoming videos. Thank you very much.